I'm happy to have this chance to talk about the analysis of ancient megaherbivore bone from southwest Madagascar, which allows us to learn a bit about past vegetation change and the disappearance of endemic megafauna such as elephant birds, pygmy hippos, and giant tortoises. I'm giving this short presentation because I agree with this statement that understanding links between grasslands and the extinct fauna of Madagascar is crucial to determining the pre-settlement extent of the C4-dominated grassy biomes. Several studies suggest that C4 grasses, including some grazer-adapted taxa, have a long history on Madagascar. And if these ancient grasslands were extensive, then we would expect there to be lots of different animals that ate grass. So the basic question that one of my committee members previously addressed and that I'll consider in this talk asks, who ate the ancient C4 grasses? Stable isotopes can help us identify who was a grazer, so I'll present stable carbon isotope data from plants and animals. I know that most of the concern regarding the past extent of grasslands is focused on the Central Highlands, but I'll focus here on my work with plant and bone samples, ancient bone samples from the arid Southwest from these sites. This histogram shows the distribution of stable carbon isotope values from hundreds of plant samples collected in Southwest Madagascar. Generally, plants that use the C3 photosynthetic pathway, including a variety of shrubs and trees like Ziziphus spina Christi, are depleted in carbon-13 and have relatively low stable carbon isotope values. Grasses that use the C4 photosynthetic pathway are enriched in carbon-13 and have relatively high carbon isotope values. And the same is true of succulents such as Euphorbia stenochloda that use CAM photosynthesis. In general, we expect grazers to have tissues enriched in carbon-13 relative to the tissue of browsers, and we expect mixed feeders to plot between these two end members. At this point, it's important to note that most, but not all grasses use C4 photosynthesis, and as you can see with data from the CAM plants, not all high stable carbon isotope values in consumers can be attributed to C4 grass consumption. So with these caveats in mind, here are the stable carbon isotope data from extinct and introduced megaherbivores from the Southwest, which are corrected so that they approximate the isotopic composition of their diet and can be compared to the plant end members at the top. The saturated bar associated with the histogram from each color-coded group gives the mean. And a couple of patterns might immediately stand out. The first is that each taxon includes individuals that relied on some combination of C3 plants and CAM plants or C4 plants. Also, extinct megaherbivores like elephant birds, giant tortoises, and pygmy hippos relied to a greater extent on C3 plants than introduced grazers like sheep and cattle. So we don't then have a clean answer to the question of who ate C4 grasses before the spread of livestock on the island. We can conclude that these animals weren't dedicated grazers for the most part, but giant tortoises and pygmy hippos could have relied on C4 grasses to a certain extent. There are lots of possibilities to learn more about past herbivory on the island. I think that basic stable isotope data are still scarce from other regions and taxa. It'd be worth sampling more in particular from the Central Highlands. In the Southwest, we've found that cattle and endemic megaherbivores ate different things, but cattle might be a closer functional replacement to endemic megaherbivores in other parts of the island. It might also be helpful to focus on analyzing smaller taxa in the future that could have relied more on open habitat. Even when we find taxa that clearly relied on C4 grasses, it's important to be clear about how to connect this with inference on past grassland extent. Madagascar is known for microendemism, so merely the existence of a dedicated grazer does not imply extensive habitat for grazers. It will also be useful to regularly compare regional records of past vegetation change with proxies of past herbivore diet. I noted earlier that if pre-contact grasslands were extensive, then we'd expect to see lots of grass eaters. But this assumes that the grazer niche was immediately filled. Other work from mainland Africa suggests that there was a lag between evolution of C4 grasses and C4 grazers, so it might be worth considering the possibility of a vacant grazer niche in Madagascar through more quantitative and spatially explicit reconstruction of vegetation and herbivore diet. So thank you for your attention. I'd be happy to answer any questions, and I must thank these people for making this work possible. Thank you.